So the purpose of this call is actually to go over a little bit, how we're going to form project teams by presenting a list of potential projects that y'all could end up working on this summer. Although if, these are just kind of the ideas that we've come up with from the work that we've been doing in the past year, but certainly if you guys have your own ideas for projects, then we're definitely open to hearing those and letting you guys work on that. So again, just to summarize, you guys can assume that in the background, we'll have a couple of different models running all the time throughout the whole Summer Institute. So the high-resolution rapid refresh model provides atmospheric forcing forecasts every hour, and it gives a 15-hour forecast ahead. And we're feeding that data into the WRF-Hydro framework and running the NOAA-MP land surface model for the whole country. And then we're connecting the surface and subsurface runoff that comes out of that model to the rapid river routing model. And we're doing that for the whole country on the NHD Plus river network. So that's about 2.67 million river reaches. So you can expect at each of these reaches, every hour you'll get a 15-hour forecast into the future. Now, in addition to that, the BYU group has been working with the data coming from the European Center for Medium Range Weather Forecasts. And so they provide surface and subsurface runoff twice a day for the entire globe. And then we're downscaling that runoff just within the United States. And again, aggregating that to the NHD Plus river network and routing the runoff using the rapid river routing model. So again, so for every single river reach, you'll have the 15-hour forecast coming from the high-resolution rapid refresh for hydro models, and you'll also have a 2-week forecast coming from the European Center for Medium Range Weather Forecasts. So this will be data that will be available, and the models will be running in the background, and you guys will have access to that if you want to center your projects around those models. Now, again, I think that we have about 50 participants for the Summer Institute, and so we would like to form teams of 3 to 5 participants each, and those teams will work together to come up with a defined project scope, and then over the course of the 7 weeks, we'll work on executing some of the tasks that you guys have come up with. So what we're going to do is, on Monday, you can expect a Google document to go out to everyone, and it'll have a list of projects, and we'll go over those today. And actually, Emily, can you switch to the Google document so we can show what that'll look like?
Sure.
Okay, cool. So it'll have the description of what you can assume will be available, and then if you scroll down, Okay, so if you scroll down, there'll be a section called Case Studies. So there's a couple areas in the U.S. that will have additional data available to help support you guys if you guys want access to more data. So specifically, in the state of Iowa, there's the Iowa Flood Center hosts the Iowa Flood Information System, and so they have their own model for the whole state. And similarly, so how we're doing simulations on about 3 million catchments across the whole country, they're doing about 3 million catchments just within the state. And so we'll probably have access to the models that they're running as well, and the additional gauges that they have set up across the whole state. So they've installed water level sensors on a lot of the bridges across the state, and I believe that data is coming out is available through services. And so if you want to focus your project specifically in Iowa and compare model results from the work that they're doing, then there'll be access to additional data within that state because of the work that the Iowa Flood Center is doing, and we can help make those connections for you. We'll also have additional data available for the Mobile, Alabama river system, and this was a lot of the work that's based out of the University of Alabama. Dr. Maiden has been making connections in North Carolina within specifically the Tar River Basin because they have a very, very detailed LiDAR data set for the entire state and have been extracting lots of cross sections as well. And so that could be an additional resource for us. And then also we're working on running a simulation during the time that Hurricane Ivan hit the States back in, I think, September 2004. And so hopefully we'll be able to show that visually to everyone, and then we can assess, or we can study what kind of impact it had on the water resources during, I think, that whole month, really. So anyway, so if you guys decide to focus your projects in these areas, then there potentially could be a lot more information available to help define your projects. After that, you'll see a list of the projects that we came up with, and these are all linked. So if you just want to browse through the titles and then just click on one, it'll take you farther down in the document where that project is described. And then, yeah, so you'll see a list of projects like this. It'll just have a title. It'll have a very brief description of that project. It'll be classified within the themes that that project is associated with, and a lot of these projects have multiple themes, and that's great. We can work with kind of bridge across those different areas. And then we ask that you guys provide your top 2 or 3 projects that you're interested in and write your name within or in this NFIE participants box. So again, this will be a Google document that everyone will have access to and that everyone can edit. So if you find 2 or 3 projects that you like, please put your name in that box. And then if you'd like to add some comments specifically to that project, then go ahead and do that in the comments box. And so again, there's about currently 22 projects listed, but if you have another idea that you'd like to work on as well, or build off of an existing project, you can either add your own project on this list, or just add comments to an existing project, and then everyone will be able to see that, and others can join the project that you proposed as well. So, we haven't set the deadline for when we'd like everyone to have provide input into this document, but I would say, you guys would have about a week and a half to go through these projects, and then by the time the start of the boot camp, we'll aggregate all the information and we'll use that to break into different groups during the boot camp, and then from there we'll start defining the project teams more explicitly. Okay, so if you guys have any questions, we'll save them, I guess, to the end of the webinar, and then we'll address them there. Okay, so can we go back to the slides?
Yeah, and while we're doing that, Barbara Minsker just came on. Barbara, can you talk and just make sure we can hear you?
Yeah, can you hear me?
We can hear you.
Perfect. All right. I just want to make sure we're all set for when my time comes.
Great.
Thanks.
Thank you. So this is the one, right, Fernando? We're on NFIE project teams?
Yeah, exactly.
Okay.
Okay, so again, yeah, you can expect this document to go out to everyone on Monday, and then you'll have about a week and a half to look through the projects and list which ones you would like to work on. Okay, so now we'll just go through just really quickly some of these projects, just so everyone has an idea of what each project is covering. So this will be the projects that are mainly dominated by the hydrology theme, although again, a lot of these projects are kind of cross-cutting across themes. The theme lead for the hydrology projects will be Ziggy Cohen of the University of Alabama. Unfortunately, he couldn't join the call today, but he will be available throughout the whole Summer Institute. So any specific questions pertaining to any of these projects could be directed to him, but then again, a lot of us will be available, so we can have wider discussions. Okay, so this project's title, Regional Model Calibration of NFIE-Hydro, and this is kind of based on, again, we're going to be having this operational framework running for the entire country, and there are a lot of assumptions that are in parameters that are estimated for setting up this model for the entire country. So it'd be interesting to have a project team dive into specific regions and areas and do some more extensive model or parameter calibration. Again, I think if the Weather Service, if we end up moving towards this national model framework, then we'll have to have a way of evaluating these models in specific smaller regions, and then taking those parameters and then bringing them back into a national operational model. So this would be a good project to kind of explore how that could be done. And of course, there's lots of different regions where this could be evaluated, and we have plenty of gauges from the USGS to use that. And specifically, again, in Iowa, we'll have additional gauges as well. So this project is just essentially looking into model calibration of specifically WRF-Hydro and the rapid models in specific regions and evaluating their performance. This next project here has to do with reservoir modeling. So currently, in the workflows that we'll have running for the entire summer, we will not be taking into account reservoirs, but we can. So specifically in the rapid model, in the file inputs, we can specify locations where we have reservoirs, and we can essentially break the model at that location and feed forecasted reservoir releases downstream. So, for example, at Granger Lake, for the river reach downstream of it, instead of taking the upstream flow, we can provide our own flow just upstream of that reach, and then that will get routed through the entire network. Now, the National Weather Service will have, they make forecasts at about 3,500 locations across the country, and some of those locations coincide with large reservoirs. And the regional forecast centers are constantly in contact with those regional reservoir operators, and so that's what they base their forecasts on. And so we will have a web service of the forecasted runout or stream flow for the whole country, and so it's possible to use that information to put it into the rapid model and then route the forecasted releases downstream instead of the upstream flow. So this project would kind of look into that. Now, there's a lot of smaller reservoirs that aren't, being where we don't have forecasts available, and so this project could also look into coming up with simple, mass balance models for those smaller reservoirs and seeing how else we can account for, all the different large and small reservoirs all over the country. Okay, so next project here, this is called Impact of High Resolution Flow Lines on Flood Forecasting. So we're currently using the 100K scale NHD plus flow lines to do the routing on, but there's also in some areas the 24K NHD plus available, and so essentially what that means is we have a lot more flow lines that we aren't currently accounting for, and so it'd be interesting to see how that affects the model results. And one of the big assumptions that we're making is once we aggregate runoff over NHD plus catchment, we assume that all that water volume goes directly into the river reach. Obviously, there should be time of concentration and delay, but we're currently not taking that into account, and so this project could also kind of look into the time of concentration, alterations to the the runoff time series that are going into the rapid model. All right, next project here. So anthropogenic impacts. Of course, there's we have a lot of land use that's changing in specific areas and then in cities that are developing quickly, and so this would be a study on what kind of impacts those changes would have on floods specifically. I think this would also be interesting to look into urban infrastructure and stormwater drainage, and maybe running some of those models and seeing how that can be integrated into the current NFIE-Hydro framework. So yeah, that kind of sums up what this project would entail. Let's see. This project is integrating remote sensing and data assimilation into flood modeling. There's a lot of remote sensing that's data that's being collected, and that information could be used at various different levels of the modeling. When common use is when we develop radar precipitation products. Those get gauge corrected, and they also get compared to remotely sensed data, data coming from satellites. So it'd be interesting to look at different data assimilation techniques and different remote data sets that are available to kind of enhance the workflow that we currently have. Specifically also, once we do the stream flow calculations, how do we take into account the gauge observations and potentially correct any errors that we have in kind of near real time so that we can get adequate initial conditions to drive these models. Let's see. All right, so this one's called Rapid Inundation Mapping, and this is kind of based on some of the work that the U.S. Army Corps of Engineers is doing. And so they're actually running the rapid model as well for specific regions. And what they're doing is in areas where they have cross-sections, where they're estimating cross-sections, they're using, I think, Manning's equation to go from flow to water level. So again, the rapid model is only calculating stream flow because it's based on, the Muskingum method. And so, one of the things that we want to achieve through this Summer Institute is getting from flow to water level, and then from water level to inundation mapping. And so, ways of getting, quick estimates of water level would be really helpful. And so, this project could look into things or methods for doing that, and specifically maybe the auto route method that the Army Corps of Engineers uses in evaluating how good that method works. There's also another model that we've been working with called the SPRINT model, and this has been developed by IBM and a professor at the University of Texas, Ben Hodges. And the SPRINT model actually solves the full St. Bernard equations at large scale. And so in addition to giving you flow, it also gives you water level. But as part of the inputs for that, you need to have cross-sections or estimated cross-sections. And so, this project could look into methods from getting from flow to water level. Joseph, is there anything that you want to add to this project? I think you know more about this than I do.
Not particularly. I guess one thing that we want to emphasize with this one is that the idea with auto route is that it works quickly and it works with very sparse data. So that was sort of the emphasis on this. It's very much applicable on a national scale because it works. It's demonstrated that it can work with very little data. So we can use, I think the Corps has been using the 1/3 arc-second DEMs to inundate. So yeah, that would be the goal here is to use the sparse data and make it rapidly estimate inundation. I think that's sort of what I would emphasize with this. Does that make sense?
Yeah, and from what I've come to understand is the Army Corps is really used to coming up, in addition to good model results, they also are good at coming up with model results very quickly and evaluating different scenarios through different simulations. And they do a lot of this work for the military, and so for that reason they have these rapid response models. And for our first responders, especially when it has to do with flash floods, we need quick estimates of what potential flooding could be happening. We'll talk a little bit more about that when we get to the response theme, but just kind of keep that in mind. There's a question here. The rapid Untitled is not an acronym, right? And that's a good question. Maybe it means both in this case. But yeah, rapid is an acronym for the model that we're using. It's the routing application for parallel computation of discharge. But you're right, in the title here could also be coming up with very quick inundation mapping. Okay, so next project listed here is model comparisons with current forecasts and observations. So, we'll be computing a lot of these forecasts at each of these reaches, and so, we haven't done extensive validation on these forecasts, and so, a very good project would be to start evaluating how we're doing and use that as a baseline for a national model, and then we can, as we make improvements and corrections, then we can compare what we had initially to what we've been improving on. And one thing, so as part of I forgot to mention this in the beginning, but as part of the ECMWF surface and subsurface runoff, what I forgot to mention was that it's actually a 52 Ensemble member forecast. And so they provide, on time series of runoff for 2 weeks with 52 different Ensemble members. And each of those members are getting fed into the rapid model And so what we're actually getting is an ensemble forecast of stream flow at every single river reach. And so one thing to look at is, how do you go about validating ensemble forecasts? There's a lot of statistics that can be computed. I mean, is it just strictly, is our actual stream flow within the range of our ensembles, or, how narrow is our ensemble band? There's a lot of different ways of evaluating those ensembles, and I think this project would look into some of those techniques for doing that. The BYU team, would you like to add anything specific to this project? I think.
Thanks, Fernando. Yeah, this is a project that kind of combines what we have tried to establish so far using ECMWF and an existing ongoing project by Andy Wood to evaluate several watersheds across the country to compare them against the current methods of forecasting. And so we kind of want to extend what Andy is doing and what we're doing both with the ECMWF and with the WRF-Hydro forecast in these different regions to see how accurate they are and how we might be able to improve them with observed data.
Yeah, and there's also this thing called the hydrologic ensemble prediction experiment. That's been kind of a community of people that have been working for, I don't know, several years now, and they work specifically on providing ensemble forecasts and how it is that we actually come up with those ensembles and how do we evaluate those. And so there's this community, and they have a webpage. I think if you just Google HAPEX, you'll find it. But there's a lot of good information there about ensemble forecasting. They have references to papers and different games and scenarios that people can work through. And it seems like that's where we need to go. And so this, what we're doing this summer is kind of, initial first step, a baseline, and from there we can, keep improving.
Exactly.
All right. Yeah. Okay. Let's see. This project here, a regional study of hydrologic modeling frameworks. Now, again, there's a lot of different, land surface models and modeling frameworks that are used across the country, and we're only using, the WRF-Hydro, NOMP, Rapid, ECMWF models, but there's a lot of other ones like BIC and the Community Land Model, and a lot of these are actually used within the NASA land data assimilation system, and so it would be interesting to also run some of these other models using some of the same forcing and then evaluate what the differences are in the forecast. So, for each of these reaches, we'll have the ECMWF ensemble forecast. We'll have the WRF-Hydro forecast. That's 53 ensembles, but then we could add more and more ensemble forecasts from different models as well. And I think that's one of the goals of this whole interoperability experiment, is really to provide this framework through which, we have this map. We can click on any single river reach, and then anyone doing modeling or forecast modeling in that specific area, we automatically through web services can integrate all those forecasts, and then we can see in some type of interface, all the different forecasts that exist, and then from there we can evaluate. Okay, what predictions make sense, and then use that to inform, either the public or the first responder community. Now, obviously, communicating ensemble forecasts and probabilistic forecasts is difficult. So, a project team could also look into how we should communicate those probabilistic forecasts, because, a lot of times the first responders want, just tell me what the number is. What should I expect? And sometimes we just don't know what the exact number is. We have a probability range, and so how can that information be converted to kind of actionable, intelligence? And so, I think that's, very much a project that would be interesting to have over the summer institute as well, kind of this communications component. All right, so let's keep going. Okay, yeah, so in a lot of regions across the U.S., we have a lot of the runoff is based on, it's driven by a lot of the snow melt, specifically in the springtime. And so I know WRF-Hydro and NOMP do account for, conversion of snow through snow water equivalent and putting that into the routing models, but are those physical methods good enough? So it'd be interesting to evaluate those basins in particular in more detail, and evaluating the snowmelt models that are available within NONP and seeing if we need to improve upon them. Specifically also in areas where there are glaciers, there are a lot more different dynamics that are going on in those areas, and so looking into assessing the validity of the snowmelt models in these regions would be really important. Again, we're making a lot of assumptions because we're setting this model up across the national at the national scale. Okay, so now switching into some more hydraulically dominated projects. The team lead for this will be Dr. Nelson at BYU. So one of the projects listed here has to do with, so we want to get from flow to water level, and we have, through a lot of different HEC-RAS models that have been used to produce FEMA flood maps, we have a lot of cross sections out there. Now, getting a hold of all these cross sections or HEC-RAS models and extracting the cross sections out, that's a project in itself, and there's a lot of issues by doing that. But I know specifically in the Mobile, Alabama river system, Joseph has access to pretty much all the cross sections in the state. Is that correct, Joseph?
Yes, yeah, pretty much every one of them. Even if anybody wants to go about the process of getting them out of the paper-based models from the 1970s, I've got those as well. Yeah,
so through the NHP Plus, we have this geospatial framework for kind of the drainage system of the whole country. But it stops at cross sections, right? We don't have a cross section database for the entire country, and so it'd be interesting if the group were to look into what a data model for cross sections would be like and how that could be tied into our existing NHD Plus network, and then use that to tie it into our simulation results and see how we can get from flow to water level. So this project kind of would deal with something like that. Let's see, next project. So again, even though we do, we have a lot of cross sections in certain areas for these flood maps, there's a lot of areas that we don't have cross sections at, and so looking into techniques for estimating what a cross section would look like in areas where we don't have that data collected would be really valuable. So then we can actually go from flow to water level across the whole region instead of just in specific areas. And specifically, like the sprint model that I was talking about earlier that solves the same Saint-Venant equations, really what's most important there is getting a characterization of the rating curve. So, because given the cross sections that you put into the model, what it's doing essentially is calculating a rating curve. And so if we can model what the rating curves look like and how those vary in space, then that would be equally as good as just having the original cross-section information, at least for that model itself. So this project would look into different techniques for extracting cross-sections out and then pulling out rating curves for use in some of these models. Incorporating 2D hydraulic modeling. So in some areas, we're gonna need techniques for going from flow to water level. Won't be good enough, and we'll need to do some extensive 2D modeling. And so coming up with a framework for how we can tie that into the existing workflows would be great. Actually running some of these 2D models like LISPA and Delft3D would be really good, and we can see what the differences are in inundation mapping, going from maybe the simple 1D techniques to maybe a more extensive 2D approach. The Weather Service has, combined with the USGS, has a project where they essentially have been coming up with a pre-computed library stack of inundation maps for certain areas. And what that allows is that based on a flow that's observed, you can rapidly see what the inundation for that flow would be. And so that's really helpful for first responders because it gives us a fast solution. Now, in the areas where we need to do this more sensitive 2D modeling, it'd be really great to be able to come up with those inundation libraries as well, and then integrate that back into our system. Dr. Nelson, do you want to add anything specific to this project?
Dr. Nelson actually stepped away, so.
No problem. Okay, that's fine.
Chad, so I'm interested in kind of leveraging with Tethys, and we'll talk about this later, but we've got a lot of distributed computing tools that would allow us to explore a large range of parameters and generate a large library. So I'm hoping we can leverage the computing tools to kind of create a large inundation mapping library like you mentioned.
Okay, great. So given it's already 11:30, I'll try to go through these a little more quickly. Okay, so another project that people could work on is looking into coastal processes. So a lot of this, the forecast that and the modeling that we're doing kind of ends right at the coast. And, there's a lot of flooding that occurs when you have storm surge and hurricanes coming through. And so it'd be really good to also tie the modeling that's done along the coast into our existing framework. So, a specific model that's used a lot is called the slosh model. So a group could look into doing some of this modeling along the coast and figuring out what inputs we need to run those models, and then how we can connect that to the routing that we're doing across the terrain itself. This is just an example figure. Some of the slosh models that are used. Not sure where this is, but I know the Army Corps does a lot of this type of modeling. Okay, impacts on river morphology. Obviously, when we have huge floods along river reaches, we're also changing what the morphology of that cross section or that section of river looks like, and so it would be good to see how big floods impact river morphology, and seeing how quickly we need to update maybe the cross-sectional information that we have on specific reaches. And so this project would look into modeling, I guess, the rivers and seeing how the morphology changes and how sediment transport is affected with big floods. All right. So now going into some of the uncertainty-related projects. I'm doing a few here, but if you guys are aware of the NASA Land Data Assimilation System, they pretty much provided a reanalysis of land surface outputs for the entire country dating back to 1979. So specifically, soil moisture and evaporation. We have time series of that across the whole country at a 1/8 degree scale. So we can compute statistics on all these and characterize what these different phenomena would look like, and then compare what our current observed values are and compare that to the history, so we can see, where along that statistical characterization we are. So how dry are we compared to what the historical observed or model observed time series tells us? Now, what would be really great is to be able to do something like that for stream flow as well. And so this work has actually been done a lot by Gonzalo Espinosa at the University of Texas, and he's been doing these statistical characterizations for soil moisture and evaporation, and a few other runoff and other variables across the whole country, and through the interface that you see here. That'd be awesome to do the same thing for stream flow. So if we take the NLDS surface and subsurface runoff, and let's say if we use that to force a rapid model for the entire country, and then get a statistical characterization of flow for each of the river reaches on NRC+, that would be very beneficial as well, because we won't know in remote areas necessarily. We won't have gauges or studies in remote areas where we can say, okay, this is actually at this flow we're actually getting a lot of flooding, right? But if we can compare that to historical flow, then perhaps we can say, oh, okay, this is a high flow compared to what we've seen in the past, so potentially there's flooding in this area. So that could be a potential project that's worked on. Looking at error, and we're dealing with a lot of models within the NFIE-Hydro, and so seeing how errors propagate between models and between different processes within those models would be really interesting to see. So altering different parameters and seeing how that affects the results would be good. But yeah, a project like this would be looking into how error propagates and the uncertainties that we have with the uncertainty we have in parameters that are within the model. This project Ensemble flood forecasting, in addition to the ECMWF forecast, there's a few other atmospheric ensemble forecasts that are available, specifically through the global ensemble forecast system. I think this is about a 1/4 degree forecast for the whole globe, and I believe we can get access to all the Ensemble runoff that's available through this system, and then it'd be interesting to connect this also to Rapid and then route that through the entire network and then provide additional Ensemble forecasting at these reaches. So this project would look into integrating some of the other Ensemble forecast systems that are available. So this is just an example of some of the Ensemble forecasts that come out of the ECMWF data sets. Okay, so now these are the more response-driven projects, and I'll let Dr. Minsker speak to these slides and projects.
Thanks. Can you all hear me all right?
Yep, we can hear you.
Okay, good. Give me 1 second to just get your screen back here. I was trying to find one thing. Where are the slides? Oh, there we are. All right, I'm good. So now, can I advance these, or do I need to ask you to advance, or how does that work?
You can use the up and arrows in the bottom left corner, and you can advance them yourself.
Got it. All right, here we are.
Perfect.
So this information that I'm going to present came out of the NFIE Steering Committee meeting in March, which was held at the National Water Center, where we'll be having the Summer Institute. And we had almost a whole day there with a whole group of emergency responders who provided input on what kinds of things they would need. And then we also spent quite a bit of time talking with Laura Myers, who is with the Center for Advanced Public Safety at the University of Alabama and had done a lot of work with first responders. So she will be working very closely with us, the teams that choose to work on this particular theme. So we have a bit more in the way of slides and pictures that I put together that I'll start with, and then the projects are at the end. So the objectives of what we're trying to do here are to design real-time tools and methods that would provide daily flood briefings for these first responders, because when an event is unfolding, they come together every day and look at all the available information and then make decisions about how to handle that particular day. And then, of course, on the fly during the day, they'll be updating as they go. And to also provide decision support, both for what is happening right now and what we forecast is going to happen in the near future, as far out as they need to be forecast in order to make decisions about what to do next at this moment. And two of those types of decisions are incident type and emergency management actions, which I'll talk about more in a moment. And then so part of this summer project will be designing what these might be, and then seeing how far can we get in our 7 weeks in terms of creating functioning prototypes and leveraging the other themes work, of course, because we'll be using models and so forth that they'll be creating. So the daily flood briefings, these are some things that I grabbed from Esri in terms of here's what a flood briefing might look like, where we want to see some kind of geospatial map of what does the situation look like. So we want to design what that dashboard actually look like. What's the extent of the flood inundation? The first responders were particularly interested in identifying swift water areas because those require different types of rescue. So we need to be able to get that information and figure out how to get that information from the modeling and the data that are coming in. They want to know what's going on with the weather and what are the vulnerable areas. Where are they? What types? Places where it may be difficult to get out because of a low water exit, and that might be the only way to get out, and so people could get trapped in a particular area if that's cut off. Critical infrastructure, hospitals, other very vulnerable places, And then vulnerable populations, maybe nursing home where there's a lot of senior citizens that are difficult to move. So those are the kinds of things that they need to know and be able to lay out to see, okay, well, here's where the flood looks like it might be going to happen. And look, we've got all these vulnerable populations in that area. How are we going to handle those? And then also the emergency response teams and resources. There are certain specialized equipment and teams, and where are those located currently? Where maybe do they need to move to, given what we forecast is going to be unfolding in the near term. So one of the questions that comes out in terms of the decision support is incident type. There are 5 different levels of incidents for flooding, and type 1 is the most complex, where national resources are called in to help out where there's a huge disaster, and then all the way down to type 4 and 5, which are the most common, where you have small teams or maybe a little bit larger teams working together. So on the fly, they have to make a decision. When do we call and say, oh, now we've escalated, this is becoming a type 2 regional problem, or now this is huge and this is type 1 and we've got to call in the federal government to help us. In order to make that call, we'll want to see the model forecasts and the error bounds that'll be coming out of some of the other themes, but also looking from a data perspective, what's the similarity of this unfolding situation to things that have happened in the past? So this is some information from FEMA that Dr. Maidment got from them about these expanding incidents. So there's a whole command structure that's put in place for operations, planning, logistics, finance. All of this is set up, and as the situation gets more complex and escalates to these higher type incidents, then the whole setup gets more complicated. There's more commands, sections, branches, groups, and then they start breaking them out geographically as well. So you might have different regions that are providing different capabilities, and there's a whole reporting structure that has to get set up. So making the call, if this is a type 1, type 2, type 3, is very important for all these other things to happen and all these teams to be set up. So it's like a military operation that happens. Another thing too is, as a flood is starting to happen and roads may be getting cut off, we have to start to provide decision support for emergency management actions. Things like, what's the safest and fastest routes for evacuation for people to get out or for people to come in and rescue people? To make a call whether people should shelter in place because it's too dangerous to try to evacuate, or should they still evacuate? Is it time to close a road or bridges? Sending out reverse 911 messages, so messages that might go from a rescuer to your cell phone telling you stay in place, don't evacuate, or do evacuate and here's the safest way to get yourself out, to have that kind of information. Other kinds of risk communication messages that might need to be there, things like videos of here's what's going on just upstream of you and this is what's coming your way, and any sort of cues that people need to know what to do. So flood alerts like this, which Dr. Meyer showed, where here's a flood alert, flood warning, severe flood, your house is going to get buried. How do you communicate that visually and have that be a cue to people that, yeah, it's time to get out, and convince them to do that because people don't want to leave their homes. And then how to deploy the resources, the rescue teams and equipment. So all of these things, this is a huge area, and there is enough room probably for all 50 students to define a project and come up with something different. So really anything that's of interest to people, I'm very happy to have anyone who wants to work on any of these aspects. Another part of this too is thinking about infrastructure damage. If we want to see if a bridge is going to close, if a dam might fail, If a building might collapse, then we need to be able to look at modeling infrastructure damage. So one of the students at the University of Illinois, Morteza, who I think is on the call, is looking at the possibility of using HAZUS MH for modeling flood damage to all these different kinds of infrastructure, and then try to predict what kinds of losses there might be and when is it time for a bridge closure or a dam evacuation, for example. And then thinking about human responses, we're trying to predict what will happen in this area when a situation is unfolding and we ask everybody to evacuate. Are they actually going to evacuate? How many? Is traffic going to get tied up? What will happen as all these individuals start making action? Then we need to create some models of human response. And I have another student who is interested in starting to look at agent-based models as a way to think about this. So you've got in this picture a flock of birds, and we want to look at a snapshot, individual birds, so we can create decision rules of what each bird is doing. And then by simulating each bird, we can see what's the whole flock going to do. And so we can try to predict what people might do. And Dr. Myers has done some surveying to understand how people behave during emergencies. And so we're going to use that data to begin to create these kinds of rules and models to simulate what would happen and how will people behave, and then we can tie that together with the other models in terms of tying it with the hydrology and hydraulics and weather and so forth. So that's kind of the overview of the whole thing. These are the specific projects which I've mostly talked about already, but this summarizes them. The decision support for flood forecasting, the daily flood briefings, then what do we tell the public about evacuation is the second one. Flash flood prediction is another one where it's difficult in the river models to know what's happening with flash floods. So we can begin to train with data-driven approaches using machine learning to predict when a flash flood might happen because it's similar to a prior storm. And then there are two last ones here, which I think Fernando is going to take.
Sure. So this project is about identifying flood hazard zones. So one thing we've thought about is intersecting the NFC Plus river reaches with the FEMA flood hazard inundation map. So essentially what we'd be doing is taking the, let's say, the 100-year flood inundation extent and extracting that out per reach. And then if we can have a method for figuring out what the likelihood of that river reach is to flood, or what the likelihood is of that reach flooding, then we could perhaps color code that flood hazard zone, green, yellow, red, or something, and then use that as a way of communicating potential hazard to the public or first responders. So something like this, for example. So this is an example of, within a catchment, we have the flow line, and we intersect that with the flood hazard layer, and then that hazard layer would get some type of color coding based on some evaluation of whether or not we think that reach is flooding or not, based on either historical characterization or something else. And this last project here is kind of taking into account the pre-canned models. So going through simulations beforehand for a lot of different inputs, and then having those results ready and stored somewhere, let's say in the cloud. And then if we experience an event that has similar characteristics to one that we have already simulated, then we could just take the results that we already have stored for that simulation and use that as an initial estimate for what we think will happen. So an example of this has been done with the geisha model, and this is work that was done at BYU. And the results are displayed through the Tethys application. So if the BYU team wants to talk a little bit about maybe Tethys and this Cascading model, maybe just for a few minutes or so, and then we can start answering questions.
Sure. So, yeah, do you mind if I just go through these real quick?
Sure. Go ahead.
As we're listening to all the different project ideas, I guess what we want you to be thinking about as you're selecting a project is not only how to accomplish the project objectives, but how to make those accessible and usable. And part of what we're going to teach during the boot camp is how to set up Tethys web apps using Tethys platform. And I think you'll see that it provides kind of a really nice mechanism for sharing your apps. So really quickly, as a reminder, Tethys platform kind of provides you with a GIS stack of software that's open source so that you can do mapping and geoprocessing. And it also provides links to CCAN and computing resources like the Azure cloud that we'll have available at NFIE. And like you were pointing out, we have the Cascading app as one of the example apps that we've developed. Actually, I'll put in the text box here, chat box, a site where you can see live demos of these apps. And what it just allows these, if you go visit the site, these plots are kind of interactive. They're intuitive to use. We have others that use maps so that you can display spatial data. So this Geisha Index Map Editor app just kind of walks you through a simple workflow to edit some of the spatial input to a Geisha model. And I think a lot of you have probably seen the stream forecaster, the ECMWF Rapide tool that Alan Snow developed here, where you can select reaches on the stream network and see kind of the ensemble forecast, or a summary of the ensemble forecast from ECMWF. And we hope to be able to extend some of these apps using NFIE, but let your imagination run wild in how you can use Tethys to make these projects accessible. Especially, I mean, they have obvious applications in the response realm, but I think there's a lot of applications in the other types of projects as a user interface. We'll be teaching a short course for a couple days during the boot camp where we're going to teach you how to set up a new Tethys app project. We'll teach you how to do mapping and plotting in Tethys and geoprocessing using the cloud computing resources that will be available. So while you're selecting projects and thinking about it, think about how you're going to present those results and make them accessible. And I think Tethys platform could be a really good option for that. That's all I have.
Okay. So that's pretty much all we have. Sorry that we went a little bit long here, but if you guys have any questions, please submit them through the chat box. But again, these are just a list of projects to kind of seed ideas, and if some of those projects may be similar and could be linked together, so that's fine. We can combine those projects and have a project team working on a couple of those different things. So anyway, yeah, any questions?
Okay, so it looks like some questions are starting to come in. Do you want me to read them to you, Fernando?
Oh, sure.
Okay, so here's a question from Caleb Wannen. We are looking at using a whole host of models, some of which need to interact with each other, e.g. converting flow forecasts into flood stage. How is this going to be accomplished? I proposed a flexible model coupling framework as part of the application for the NFIE Visiting Scholars Program. Are we abandoning the proposals from the Visiting Scholars altogether?
So we're not necessarily abandoning those proposals, but we just asked that if you could provide that that proposal into the common Google Doc that we'll have, then in that way we can gather interest from other people. So again, we want everyone to be a part of a project team, and so we want to not only meet the interest that you have, but also accomplish kind of a greater goal that the team would establish. And so this Google Doc is kind of the first step for organizing people's ideas, and then during the first week of the boot camp, we will elaborate on those and split into specific project teams, and then have more intensive discussions as to what that team is going to accomplish. As for the flexible modeling framework, you know, I don't have a good answer for you. I think that's something that we'll just have to discuss when we're all in Tuscaloosa, so that we can specifically see what it is that everyone is doing and proposing.
Okay, we have another question from Chad. So are there any references you could provide or recommend that describe some background on the different hydraulic models that will be used?
Sure. We can send out some references. But yeah, we can send out some references beforehand, but we'll also cover a lot of these topics and models during the boot camp, and we'll certainly have links to more references then. But we can, as a first step, I would read through the NFIE conceptual framework paper that David Maidman wrote. It's on the NFIE website, but we can send some additional references out, like links to WRF-Hydro model or ECMWF and Tethys and things like that.
Okay, and a question from Tim Petty. So to be clear, the idea with Tethys is that I can select one project and use Tethys to illustrate.
Sure, absolutely.
So this is BYU. We can respond a little bit to that. I mean, any of the projects could use Tethys, and you could extend an app that's already there, or you could create your own app. Really, what Tethys is designed to help with the modeling and computing, so it really, I think, will help accomplish the projects, but also it provides a great way to communicate and display the results of your projects.
Yeah, and as part of the Summer Institute, every project team will have access to some resources on Azure, so everyone will have a virtual machine there that everyone can log into and can set up models or applications. We're also looking into giving access to a supercomputer, either at TAC here at UT or locally in Alabama. So there'll be several options for executing your projects, in addition to your local laptops.
Okay, great. And it looks like there's still some typing happening. So while we're waiting for the next question, I've just brought up this note screen that has a couple of reminders on it. So if you haven't already, please fill out the participant survey that was sent around. I'm going to put the link in the chat box. We really need this information to finalize some of the logistical aspects at the University of Alabama, as well as, for example, make the rooming list. So if you can get that in by Monday the 18th, that would be super helpful. Also, make sure that you're sending your photos to jcannon@fa.ua.edu for your action cards. People who are current University of Alabama students can use their existing action cards, so you don't necessarily need to have a new one. Also, return your signed Student Recreation Center forms to me. And send me your flight information and your preferred shuttle information. If you're having any issues with the flights or the shuttle times, please feel free to contact me as well. So again, if you can try to have all this information back to me by Monday, May 18th, that would be helpful so that we can finalize the details that need to happen ahead of time. So another question has come in from Maximus. Is there a bibliography somewhere that lists the work that has already been accomplished? For example, if someone wants to work on the statistical modeling of flood flows, it would be great if we have access to the work that has already been accomplished. Are we looking to improve the model or build a completely new one?
Okay, so I mean that a good start for seeing what has already been accomplished would be the NFI conceptual framework paper that's on the NFI website. We will go over what I went over at the beginning of this call is what will be done essentially. For more detail on that, there's been a lot of other parallel work that's been going on related to this, and a lot of those participants will be part of the NFI as well, and will be there during the first 2 weeks of the boot camp. So we can talk to those people who have already started looking into some of these issues and hearing from them what they've already done. I would say we could both improve the models that are already running or build something new if it's necessary. I think that's something we'll discuss when we're down there and while we're figuring out the scope of the project.
Okay, great. So I don't see any more questions coming in. Fernando, do you want to just reiterate how the participants will get access to this document? You said it'll be to be emailed on Monday?
Yeah, so I mean, we have everyone's email addresses, so we will send out the link to that specific Google document as late as Monday afternoon, and then everyone can bring that up and start editing and adding to what's there. So, yeah, it should be pretty self-explanatory. But just expect an email on Monday.
Okay. Great. So if there's no more questions, I don't have anything to add. Does anyone else on the line have anything further?
Yeah, Emily, this is Joseph.
Sure.
I was wondering, this came to mind just because we were talking about Monday. This next week is the EWRI conference in Austin. I don't know if anybody else is going, but it might be a good time to kind of maybe meet together, formally or informally, with anybody that's going. I just wanted to toss that out there because I know Dr. Maven will be there. I'll be there. Fernando will be there. We'll have a lot of people there, so I don't know if that's something that we want to get together.
Great. That's a good idea. Thanks for bringing that up. I don't know what the best way to arrange that is. I don't know if you want people to contact you directly if they will be attending.
Emily, I guess last time somebody had talked about putting up a Facebook page or
I think Solomon put one together. Is that right?
I think so. I'm not sure. I can dig that link out and kind of send that around again. I don't have it right at my fingertips. And I don't know if people have been using that or not, but that is a good idea. We can try to get that going. Oh, Fernando's got it. Great. Thanks, Fernando. So yeah, I guess if you are going to the EWRI conference and you want to try to meet up together, and just go ahead and post to the Facebook page. Is that the best way to do it?
Yeah, I think so. I think that would probably. I'm not even in the Facebook group. I don't think.
Yeah, I don't think I've been following it too closely, but this is a good idea. So I'll get it posted to the NFI website, and then we can kind of go from there.
Cool.
If there's a enterprising soul who wants to go ahead and create a LinkedIn group as well, that might not be a bad idea.
Yeah, that's a good idea. So
I think I can do that real quick.
Okay, yeah, if you want to do that, just go ahead, and then if you send it to me, I can send that around as well.
Okay.
All right, but if no one else has anything to add, I think that we can wrap up. We've kind of gone over an hour now. So thank you, everyone that contributed and spoke this afternoon. I think this was really helpful. And for NFI participants, you can expect an email on Monday with access to the Google document. Also, this webinar was recorded, so it'll be posted to the NFIE page as well if you want to go back and review anything that was covered. Okay?
Sounds good.
All right. Well, thank you, Fernando, and thank you, Dr. Minsker and the BYU group and Joseph and Dr. Ernest. So we will be in touch.
All right, thank you.
All right. Thanks.
Bye.
Have a good one.